in chapter 21, we aren't doing anything really new, like big concept-wise. It's still just talking about confidence intervals and hypothesis tests that we've already done. So it's not like you're learning something brand new. Like I said before, this unit breaks everything down for you, all right? So that we've done this at a slow pace. Like we've talked about sampling distribution models, and then we talked about confidence intervals. Then we talked about hypothesis tests. This chapter goes in more detail about hypothesis tests. And then for every other chapter after this, it condenses all of that into one chapter. So chapter 22, the end of this unit, is still about confidence intervals and hypothesis tests. It's just about a new one, and it's all together. Like I told you earlier this year, you're going to get bored with the repetitive nature of what you're supposed to be doing, but all the statistics change and the mechanics change a bit. So you'll be fine. Again, we're going to have a test at the end of chapter 22. That way you have 2 test grades this 9 weeks. Okay? All right. First thing, these are things we've already talked about, but I don't think that everyone actually understands them yet. So I'm going to keep saying it until people understand. First of all, the null hypothesis. All right, the null must be a statement about the value of a parameter for a model. You guys know how to write the null hypothesis and the alternative hypothesis. This is not new. Here's the problem. When you do a hypothesis test, you're doing the entire test based on the idea that the null hypothesis is true. But some of you guys are not doing that, and so you're confusing yourself. So in a hypothesis test, you're given a p and a p hat. If you have a null hypothesis, you're in the entire test pretending that it's true. That way you can see how big of a difference, like what that probability would be at the end if the null hypothesis was true. What happened? Okay? So that means when you write your hypotheses, you have your null and alternative. When you check your conditions, you check them about the null hypothesis. So when you do success failure, you do not use p hat, you use p. When you do your mechanics, even though the notation says the standard deviation of p hat, it's not really using p hat. We're doing this given the null hypothesis is true, so you are using p. The only place you use p hat in the entire hypothesis test is to find the z-score, because it's a standardized score. That's what a standardized score does. It compares 2 values. So you can then compare p and p hat, and that's when you get your z-score, and you find a probability. You're using a normal model with a mean of 0 and a standard deviation of 1. Probability should not be difficult to find. Right? So then at the end, your entire conclusion is based on your null hypothesis. And what I'm getting is like bits and pieces of stuff, but not actually the entire statement that you need. I'm getting things like the p-value is high, and that's the proportion of the time the null hypothesis is true. That is not what I said. All right? So let's go through this p-value situation again. I'm going to keep saying it until all of you guys get it, because it's going to be the same every single time. If your p-value is low, let's say 3%, all right? That means 3% of the time, you would get a proportion, like a sample proportion, like you got in the problem, if the null hypothesis was true. So if it's low, we reject the null hypothesis because that means it's a surprising result. It's not going to just happen that we got this sample all the time. No, definitely not it. 3% of the time, we will get a sample proportion like we got in the context of the question if the null hypothesis is true. If your p-value is high, so let's say it's 22%, we fail to reject the null hypothesis because that means 22% of the time you're getting the sample proportion, the p-hat that you got in the question. If you can get the p-hat 22% of the time, if you kept doing these samples over and over again, that is not surprising at all. That is not unlikely. That means you're going to you could get this again and again. Again, it's only if the null hypothesis is true. And you're saying that because you did the entire test based on the null hypothesis. You don't get to say those things when you mess up and do everything based on p hat. The flip side of that is confidence intervals. If you have a confidence interval, It's an estimate. What is the confidence interval based on? P or P hat? P hat. Hypothesis based on P. Confidence interval always based on P hat. Right? You have to keep those things separate. Because again, we're going to start adding in new things. And it's not always going to be P and P hat. Your hypothesis test is based on your parameter value, the true population, whatever. Your confidence interval is based on your statistic, which is a sample. Okay? Keep those things in mind. So, when you have to explain what a p-value means in context, which is going to happen on the AP exam probably, in multiple choice form or not, maybe for your response form, this is what you need to say. This is a perfect example of what we've been saying. The other one is kind of a little bit different. Assuming the null hypothesis is true, the probability that our sample would produce a statistic, in this case, the statistic is a proportion, at least as extreme as the one we observed, is about, and then you give the p-value, is about 2%, is about 17%. This is too unlikely to have occurred by chance, or if the p-value is high, this is not too unlikely to have occurred by chance. That's a good way. I've given you other sentences, but that's another good sentence. You have to be able to explain the p-value. If you're going to put this in context, then when you say that our sample would produce a proportion, you would say a proportion of whatever your proportion's about. That puts it into context. Okay? You have to be able to write that down. So when I'm looking for conclusions, and I told this before, this is not new information. I'm looking for you to write your conclusion as in you rejected or you failed to reject. You give the correct reason why, and then you explain about the p-value in context. Okay? And we're still working on this p-value in context situation, so gotta get better. We have at least 4 more tests coming up in the next month and a half, but we're going to have to be able to say the same thing about the p-value. All right? Okay. Questions about p-values? Nope. Now, when we reject a null hypothesis, then we say it's statistically significant results. All right, if you've ever seen that, or if we've talked about it in class. So if you reject a null hypothesis, that means it's statistically significant. But just because something is statistically significant does not mean that it's important. Okay? For example, back when we did a hypothesis test, the very first one I did with you guys in class was about absentee rates for students in the United States. And P was like 34%, and P hat was 33%. We ended up getting a p-value where we was low, and we rejected the null hypothesis, which means we thought there was evidence that the absentee rate was changing, right? But if we're talking about nationally, like every student in the United States, and there's only a 1% difference between P and P hat, do you think that's an important result? Probably not, right? It's a 1% difference. That's not like a 10% difference. So even though it was statistically significant, it was not important. Another way to show that, if our P is 34% and our P hat is 33%, and let's say we do a 95% confidence interval based on P hat, is our confidence interval probably going to contain 34%? Probably. Think about your confidence intervals you've made. Most of the time they are within 3 and 4% of P hat, right? So that P would be in our confidence interval, so it's not like it's something extraordinarily different, right? So, just because it's significant does not mean important. So, for example, public health officials believe that 90% of children have been vaccinated against measles. A random survey of medical records at many schools across the country found that among more than 13,000 children, only 89.4% have been vaccinated. A statistician would reject the 90% hypothesis with a p-value of p equals 0.011. So part A says explain what the p-value means in this context. I just give you a great sentence you could use. If you don't want to use that sentence, use a different sentence. But that's exactly what we've been talking about. Explain it in context. So, the one that I generally use. There is a, what was that, 1.1% chance that we would get, sorry my pen is crazy. The proportion of measles vaccinations, I'm saying this out loud, it doesn't look like anything I'm saying. In our sample, given the null hypothesis is true. I'm sorry that you can't even read that. So there is a 1.1% chance that we would get the proportion of measles vaccinations, like in our sample, given the null hypothesis is true. So if it was 1.1% chance, would we reject or fail to reject? Reject. P-value is low, so we reject, right? Now, part B says the result is statistically significant because we rejected. That's what it means. But is it important? Comment. Is it important? What is our P and what's our P hat? Right, P is 90%, P hat is 89.4%. What difference is that? 0.6%. So do you think the result is important? Probably not. Again, if you created a confidence interval based off of P hat, 90% is probably going to fall in that confidence interval. So it's really not any different, right? So it's not important. Questions about that? So don't think that your results are like this great, groundbreaking, important information just because you reject the null hypothesis. It doesn't have to be. Maybe it is. I'm not saying it can't be, but it doesn't have to be. Not really. It kind of depends on the context. But here we're talking about children all over the United States, right? This is a large sample size. If you're talking about a smaller sample, maybe it'd be different. But it's only 0.6% different. Like, that's ridiculous. I'm really sorry you can't read anything I write. Same thing about the p-value we've been talking about for a week. That's what a p-value means. If we have a p-value of 0.011, that's a 1.1% chance that you're going to get the proportion of measles vaccinations like we got in our sample, like this 89.4%. So if we kept sampling, we did another 13,000, another 13,000, another 13,000, did a sampling distribution model, we would get 89.4% again. Right? That's unusual, unlikely. So that's why we say that we reject H0. But again, that entire test would have been based on P of 90%. So that's why I say given the null hypothesis is true. It's based on the null hypothesis. Other questions on this question? No? Yes? Okay. They have one more thing to talk about today. Confidence intervals and hypothesis tests. Confidence intervals and hypothesis tests are built from the same calculations. I think you would all agree. You check the same conditions, use sampling distribution models for proportions. It's all kind of based on the same thing. They have the same assumptions and conditions, and as we've just seen, you can approximate a hypothesis by examining the confidence interval. So when we were talking about significance and importance, we were thinking about how we could use a confidence interval, and if the p was in it, then it probably wasn't important, yada yada. Well, you can also use a confidence interval to estimate a hypothesis test just in general. I don't think that's best practice. They won't ask you to do that in the AP exam. You should do a hypothesis test. Like, you should not just skip that and do a confidence interval. All right? But for certain things, you maybe only have enough information to do a confidence interval. If they only give you p hat, can you do a hypothesis test? No. Then the only option is a confidence interval, right? Okay? So, you just ask whether the null hypothesis value is consistent with a confidence interval for the parameter at the corresponding confidence level. So that's all that means. Is, let's say we do this confidence interval based off a p hat of 5%, okay, 95% confident, and we get this interval, right? Well, then in the next part of the question, they say, oh, well, here's what we think p is. Well, if p is in your interval, right, then we probably don't have enough evidence to reject the null hypothesis, right? We probably are not going to, we're going to fail to reject. If your p ends up being outside of that interval, well, that might be important, right? It's outside, your 95% confidence is going to be in this interval, but it falls outside, right? So then maybe you have evidence to suggest that you could reject the null hypothesis, right? So you can use a confidence interval. If you use a confidence interval, you don't get a p-value, right? So you don't really have an alpha level to compare that to. But if you're using a confidence interval, you can easily figure out an alpha level that you could have used that would have been reasonable. All right, so think this through with me. Confidence intervals are two-sided, right? Plus minus. So do you agree confidence intervals are two-sided? Okay. So if you have a 95% confidence interval, then the alpha level would just be 5%. That's what's left over from 100. Okay? Again, you're not doing the test, so you're not even using it. It's just this would be a reasonable alpha level. Does that make sense? So if the confidence level was 98%, what would your alpha level be? 2%. Now, are hypothesis tests always two-sided? No, they're only two-sided if you have not equal to, right? So if they're only one-sided, you would have to divide that alpha level in half, right? So if you have a 98% confidence interval, we just said the alpha level would be 2%. But if you were doing a one-sided test, it would only be 1%. All right, and we'll get into more on that a little bit tomorrow. But I have an example to kind of talk you through this, and I'll give you the assignment. Okay. In August 2004, Time magazine reported the results of a random telephone poll commissioned by the Spike Network. Of the 1,302 men who responded, only 39 said that their most important measure of success was their work. So part A says, estimate the percentage of all American males who measure success primarily from their work. Use a 98% confidence interval and check the conditions first. I'm not going to write this all out because you guys know how to do a confidence interval, or at least you should. So, if you're going to do a confidence interval, what conditions do you check? This is an assumption, not a condition. So for the independent assumption, you check two conditions, which are what? Randomness. So is this random? Yes, it says the results of a random telephone poll. What's the other condition for independent? 10%. So is 1,302 men less than 10% of all men that have a job or whatever? Yes. What is the other assumption? That's the condition. What's the other assumption? Sample size assumption, which is backed up by the success failure condition, right? So we would need to figure out, well, we don't actually figure out the p-hat at all, right? We have 39 successes, and then 1,302 minus 39 would be the number of failures. Both of those are greater than or equal to 10, right? All the conditions are met. Now that you're in the habit, you know how when we do a hypothesis test, we write a statement at the end of the conditions? You should be doing that for intervals too, because it's generally the same thing. So, because the conditions are met, we can use a sampling distribution model for proportions, a normal model, and use a one proportion Z interval, right? I will get used to saying that because in the next part of the unit, when we start doing other confidence intervals, other tests, you'll name it. I do that because most of the free response questions ask you to name it by name or by formula. And those of you that forget to write everything out need to name it by name. Okay? Checked all the conditions. So if you have a confidence interval, you have p hat plus or minus z critical value times the standard deviation, right? Or standard error, not standard deviation. So it's an estimate. So p hat is 39 divided by 1,302, which is 0.03. How do you find the z critical value for 98%? Go to inverse norm and do 0.01, right? There's 2% left. You're doing half of it, so 0.01. Ends up being 2.33. And then we have 0.03 times 0.97. Right? Your interval ends up being 0.019 to 0.041. Any questions about how I got any of that? I know you guys are all seeing confidence intervals before, so I'm not going to work every single step out. Yes. That's p hat. So p hat is 39 divided by 1,302. Again, you guys can do confidence intervals. This is not new. Everyone okay with that part? That's part A. What should you end part A with? A statement. I am 98% confident that the true proportion of men who measure success primarily from their work is between 1.9% and 4.1%, right? Some of you guys aren't doing that. Just because no one asked you directly for that statement doesn't mean you don't get to say that statement. It's a requirement. Okay? All right, so on part B, some believe that few contemporary men judge their success primarily by their work. Suppose we wish to conduct a hypothesis test to see if the fraction has fallen below the 5% mark. What does your confidence interval indicate, and explain? If we were going to do a hypothesis test, we need hypotheses. So what would your hypotheses be? .05, because they give us this 5% situation in the part B. And so what's the alternative? So if it's fallen below. So is this a one-sided test or a two-sided test? One, okay. Now it says, what does your confidence interval indicate? Is 5% in my interval? No. So I would say 5% is not in my interval. That is evidence against the null hypothesis. Now, we don't have a p-value, so I don't get to formally reject or fail to reject. We don't have a p-value to do that with. But I have evidence against the null hypothesis, right? I have evidence there's been a change. Okay? Just with the confidence interval. Does that make sense? Okay? Well, in part C, it says, what is the level of significance of this test? So I'm using this interval to estimate this test. So what alpha level would I be using, even though you don't have a p-value? If this was two-sided, or this is a 98% confidence interval, if it was two-sided, what would the alpha level be? 0.02. But it's one-sided, so what's the alpha level? 0.01. Right, it's just that divided by 2. We're good with that. Questions about where any of that came from? Especially questions about part B where I'm making a conclusion.